Welcome to Homework Lib.
So in this question, we have a PN junction. And in this PN junction, we know that the saturation current for this PN junction is 0.500 milliampere. So we want to know when the temperature is 290 K, T equals 290 K, what is the current for this junction when the voltage takes a range of different values. So we have a couple questions for this. We have what happens when the voltage is 1.00 millivolts? What happens when the voltage is negative 1.00 millivolts? What happens when the voltage is 100 millivolts? And what happens when the voltage is negative 100 millivolts? And then we want to know, is there any case, is it possible that this diode actually obeys Ohm's law? Which is to say, obviously, it will not obey Ohm's law for some of the values. So, in order to solve this question, we need to first pull out the equation of a PN junction. For a PN junction, the current that goes through it is a function in terms of the saturation power and voltage and temperature. Okay, T. So, okay, this is the current for at the temperature for a PN junction. So for question 1 to 4, what we're really doing is we're just plugging in this equation with a range of different voltages. I will do the first one as an example. So the first one, I have I equals Is times e to the EV over KT minus 1. Saturation power is 0.500 milliampere times exponential of E. E is charge carried by an electron, 1.6 times 10 to the negative 19 coulomb. Voltage in this case is 1 millivolt. So 1 times 10 to the negative 3 volt. K is just a constant, 1.381 times 10 to the negative 23 joule per Kelvin. And finally, temperature is 290 Kelvin. Whole thing minus 1. Okay, so if we calculate this, we will get a current of 0.04, 204 milliampere. So this is what happens when the voltage is 1 millivolt. And for the following questions, the only thing we need to change is we will need to change this number to negative 1 times 10 to the negative 3 to positive 10 to the negative 1 and negative 10 to the negative 1. And it turns out, when you calculate it, for negative 1 millivolt, the amount of current is negative 0.0196 milliampere. For 100 millivolts, again, same equation. So current is 26.8 milliampere. And finally, for negative 100, the current is negative 0.491 milliampere. So you can see that for the PN junction, when the current goes in one direction versus the current goes in the other direction, when the voltage is applied in one direction or if the voltage is applied in the other direction, the amount of current that goes through the junction is different. In other words, it is a directional diode. So that is for part A. Then this is all for part A. Part B asks us, is this possible that this junction could obey Ohm's law for some range? Well, if we have a look, when it's 100 millivolts, obviously when the current is applied in one direction or the other, the voltage is applied in one direction or the other, the current differs a lot. But when the voltage is a little bit smaller, the current, they differ a little bit, but not that much. So what that tells us is for small voltage, how small? Well, I mean, this question, part A, gives us a relatively good reference that between 1 millivolt to negative millivolt. One millivolt to negative millivolt. So in this case, the resistance seemed to be roughly constant, and Ohm's law might be a good approximation. So that, and also just another thing is, if you know what Taylor's series is, you can do an expansion of the exponential. I'm not going to do it here because technically you don't really need it for this question. But if you do a Taylor's expansion, you'll see that this behavior is roughly linear if this power for if this number is small enough. And again, in this case, since we already calculate and what 1 millivolt is in part A, we're going to say small enough refers to plus or minus 1 millivolt.